Hi, I'm Connor.
I'm Avery.
And I'm Milo.
And we are
The Math Gang.
Today we're going to be talking about linear programming and how much food bunnies should get. Avery, can you tell us our problem?
In order to ensure optimal health and thus accurate test results, a lab technician needs to feed the rabbits a diet containing a minimum of 24 grams of fat, 36 grams of carbohydrates, and 4 grams of protein. But the rabbit should be fed no more than 5 ounces of food per day. Rather than order rabbit food that is custom blended, it's cheaper to order Carrot Crunch and Bunny Munch and blend them for an optimal mix. Carrot Crunch contains 6 grams of fat, 12 grams of carbohydrates, and 2 grams of protein per ounce. It costs 20 cents per ounce. Bunny Munch contains 12 grams of carbohydrates, 12 grams of fat, and 1 gram of protein per ounce at a cost of 30 cents per ounce. What is the optimal blend?
Thank you, Avery. Let's get into this programming. Now it's time to find our equation of variables. For this, we'll be using x and y as our variables. X will equal ounces of Carrot Crunch, and y will equal ounces of Bunny Munch. Our first equation will be for fat. Carrot Crunch has 6 grams of fat in it, so this will be 6x, plus 12y, because there's 12 grams of fat in the Bunny Munch, are greater than or equal to 24, because they need at least 24 grams of fat in their diet per day. Next is carbs. Both the Carrot Crunch and Bunny Munch have 12 grams of carbs in them, so this will be 12x, representing Carrot Crunch, plus 12y, representing Bunny Munch, is greater than or equal to 36, because the rabbits eat 36 grams of carbs in their diet per day. Next is protein. The Carrot Crunch has 2 grams of protein in the food per ounce. And the Bunny Munch has 1 gram of protein. This is greater than or equal to 4, because the rabbits need at least 4 grams of protein in their diet per day. We have 2 more constraints to put on. Since we're working with physical things, we know we can't have negative of anything, so we need to set some parameters and keep the system to the positive quadrant. So we need x is greater than or equal to 0, so the result cannot be less than 0, and y is greater than or equal to 0, so the result cannot be less than 0 on that side.
Now we're going to simplify our equations by subtracting 6x from both sides, and then we are left with 12y is greater than or equal to negative 6x plus 24. Then you divide by 12 from both sides, and you are left with y is greater than or equal to negative 1/2 x plus 2 to get it into y equals mx plus b form, which is easier to graph. To simplify our next equation, we're going to be doing the same thing by subtracting 12x from both sides. We will be left with 12y is greater than or equal to negative 12x plus 36. Then we're going to divide by 12 again from both sides, and we're left with y is greater than or equal to negative x plus 3. Just as the other 2 equations, we're going to get it into y equals mx plus b form by subtracting 2x from both sides, and we're going to be left with y is greater than or equal to negative 2x plus 4. Last equation, we're going to subtract x from both sides, and we will be left with y is less than or equal to negative x plus 5.
The graph we are about to make, the x-axis will represent ounces of Carrot Crunch, and the y-axis will represent ounces of Bunny Munch. Now let's plot our lines. Our first line is y is greater than or equal to negative 1/2 x plus 2. Next is y is greater than or equal to negative x plus 3. Y is greater than or equal to negative 2x plus 4. Our 2 constraints are x is greater than or equal to 0, and y is greater than or equal to 0. Our final line is y is less than or equal to negative x plus 5. These are our 6 lines and form our region. The area that fits all constraints is called the feasible region. Our corner points for this region is 0, 5, 0, 4, 1, 2, 2, 1, 4, 0, and 5, 0. One of these will be our optimal point.
Now we will find our function, which will help us determine our optimal point. we're going to multiply X Carrot Crunch by 0.20 and Y, which is Bunny Munch, by 0.30, because these are the prices per ounce of each food. Now that we have our function and our points, we can plug the points into the function. For our first point, 5, 0, we will multiply the 5 by 0.2 and add that result to 0 times 0.3, which will give us a total of $1. Our second point, 0, 5, we will multiply the 0 by 0.2 and the 5 by 0.3 and add those together, and that'll give us a total of $1.50. For our third point, 0, 4, we'll multiply the 0 by 0.2 and the 4 by 0.3, add those together, and that'll give us a total of $1.20. And for our fourth point, 1, 2, we will multiply the 1 by 0.2 and the 2 by 0.3, and that will give us a total of 80 cents. Our fifth point is 2, 1, so we'll be multiplying the 2 by 0.2 and adding that to 1 times 0.3 to give us an answer of 70 cents. And for our last point, 4, 0, we'll be multiplying the 4 by 0.2 and the 0 by 0.3 to give us an answer of 80 cents. Now you can see our optimal point is clearly 2, 1, coming out with the cheapest option of 70 cents.
We now know what happens if we use the numbers laid out in the problem, but let's think of something more interesting. What if we change the function to be optimized at a different point? Instead of having Carrot Crunch be 20 and 30 respectively, what if we have Carrot Crunch and Bunny Munch be $1 and 50 cents respectively? Let's solve this new function. So for the first one we have 5, 0, so that would be 5 times $1 for the 5 ounces of Carrot Crunch and nothing for the Bunny Munch. That will equal $5 in total for 5 ounces. Next is 0, 5, so that would be no ounces of Carrot Crunch and 5 ounces of Bunny Munch. Bunny Munch is half the price, so that would be $2.50. Next, we have 0, 4, so 0 of Carrot Crunch and 4 of Bunny Munch. 0.5 times 4 is 2, so a little bit less expensive than before. Next, we have 1, 2, 1 Carrot Crunch, 2 Bunny Munch. 1 times 1 is 1, 0.5 times 2 is 1, so that's also $2 just like before. We have 2 more ones to go over. 2, 1, and 4, 0. So that would be 1 times 2 for the 2 ounces of Carrot Crunch and 1 ounce for Bunny Munch. Together that equals $2.50. Finally, we have 4, 0. No ounces of Bunny Munch, 4 ounces of Carrot Crunch. So that would be 4 times 1, and that equals $4. Looking at this, we know the two most effective combinations are 1, 2, and 0, 4, both equaling $2.